All right, so here's my solution for anagrams. Again, there's many ways of doing it, but the way that I wanted you to at least try was to solve it with a frequency counter. Use an object, construct it using a loop, and then use a second loop that's not nested, so we still maintain our big O of n, time complexity. Here's my version. So it's called valid anagram, and it takes two arguments, first and second, that's what I called them. And the very first thing I did, just like before, if the length of those two strings is different, if they don't match, then immediately we can throw it out. There's no way for it to be true. There's no possible anagram of two strings that are of different lengths. They have to be the same. So I returned false right away. Then what I did was made an object called lookup. You could call this frequency counter, just object, obj. I wouldn't call it object. It's a bad idea, but obj is okay. So lookup, and I'm going to loop through the first string right here, and I'm going to create an object that is a breakdown of the first string. So if I called valid, let's just grab one of these examples, like this one right here. So this should return true. And the first thing that I'm going to do, I'll just model this object here. We're going to go through, we loop over it. So I starts at 0, I is less than first.length, I++, so it's going to loop over this first string, which is called first. And I'm going to take the first character the very first time through. I'm using a variable called letter just to make my code a little cleaner instead of writing first I all over the place. So this letter is going to start as A. And I'm going to check if my lookup object already has A in it. And it's empty right now, so it doesn't. So this line is going to either set it equal to 1, or we're going to add 1 if it's already initialized to a value. So in our case, there is no A in our object, if this is our object. So we add, or we initialize it to 1. This is not true. It returns falsy because there's nothing in there. And so we set it to 1. So we set A equal to 1. Then we go through for n, and we set n equal to 1, right? Then we get to A again. And this time we look up A. Well, A is already in there. So this time, this part runs. We add 1. Lookup of A plus equals 1. So we set it to 2. Okay, so we construct the entire object first. And just so you can see what that looks like at the end, I'll console.log lookup right here and run my code. This is what we start off with. So I constructed this lookup, and now we're going to actually use it. So we're now going to loop over the second string, and we're going to compare each character to our lookup object that we created based off of the first string. And what we'll do is, because we have multiple, like A is in here twice, right, or 3 times, so we can't just check is A in here. We need to make sure A is in there exactly the number of times, and they're equivalent. So what we'll do is subtract 1 from A. So if we start at n, we're going to find n, and then we'll subtract 1 from n and set it to 0. If we find A, we're going to go to A and subtract 1. So now we need to find 2 more A's, and we keep going. So just to show you that, we loop over the second string. We make a placeholder variable called letter that is just going to store the individual letter, like n at the beginning. And the first thing we do, if we can't look up that letter, meaning it's not in there, like if we were looking for an S and there's no S in here as a key, then we return false. We're done. Otherwise, we subtract 1. So we go through n, we look for n. All right, well, it's set to 1. Well, now we subtract 1 and it's set to 0. And so now we go through again, and we're looking at A. So we find A, we set it to 2, and then we move on to G. We set G to 0, we subtract 1. Then we go to A again, we subtract 1. Then we go to R, we subtract 1, it goes to 0. Then we go to A, we subtract 1 again, so it goes to 0. And then we go to M, and we subtract 1, and we're done. And so we don't have to do any check at the end. We don't have to see is everything 0 or anything like that. Let's say somehow, what would be an example? If we had some random letter here, like an S, like this, so we'd have S is set to 1, and we have another M. So we just did this M, and we crossed it off and set it to 0. Then we get to an M again. Well, this time we look up letter, and it's going to give us, what is the value for M? 0. So because 0 is falsy, if we run not lookup of letter, not 0, that means this is true, so we will return false. So if we ever encounter 0, that means that there's a problem, because we've exhausted, basically what this represents are the characters that we've gone through in our first thing. So all we have left is an S. There has to be one S over here in order for there to be a match. And if instead we get to a 0, that means that we're working on a character in the second string that didn't exist in the first string. So it's a nice, simple solution, I think. I kind of like it. I think it's kind of cute. It involves, just 2 simple loops. It does not involve nested loops, which you could do easily. We could start with an A here and loop over this string and then look for an A in the second string. Then we could start with an N and look for an N in the second string, and that would involve nested loops. And of course, we would also have to pay attention to making sure that we were crossing things off or removing things as we went, so that we were not, getting a false positive. Hopefully, you can see how it is a helpful pattern in this scenario. Anytime you have multiple pieces of data and you need to compare them, in particular, if you need to see if they consist of the same individual pieces, whether it's anagrams or you're trying to see if if one array is equal to another array squared, each individual piece, or what else have I seen? If you need to tell if numbers consist of the same digits, just in a different order, there's a lot of applications for this. Anyway, moving on to our next pattern.